Usually when we sit down to do one of these deep dives, I have a pretty firm grip on the terrain before we even hit record.
Right.
We've got the stack of research, we've got the articles, and I usually feel like, okay, today we're going to learn about the history of supply chains, or we're going to figure out how LLMs work. It feels containable.
Meaning you can wrap your head around it without feeling like your head is going to, explode.
Exactly. I feel grounded. But today, after reading through this stack you sent over, I feel like the floor has effectively dropped out from under me.
It is a bit of a vertigo-inducing topic today. I'll give you that. It demands a certain level of comfort with uncertainty.
Vertigo's putting it lightly. We are looking at a stack of sources that basically asks the biggest question you can possibly ask. Not how does the economy work or who won the war, but what is this?
This, yeah.
Like this. The table, the microphone, the air, my hand. What is reality?
The fundamental stuff.
Yeah.
The substrate.
Yeah.
It's the question that sits underneath all the other questions.
Right. And usually when you ask that, you get a philosophy lecture. But these sources aren't just philosophy. We've got quantum physics, we've got information theory, we've got ontology. And the answer they are proposing is, well, it's disturbingly different from how I live my life.
It's disturbing because it challenges the two main categories we all use to navigate the world.
Oh.
We're stuck in some very specific, very rigid ways of viewing reality.
Yeah, the gradient ontology material called me out on this immediately. It basically said, look, you, the listener, and the host, you probably think the universe is one of two things.
And you probably don't even realize you think that.
Not at all. It's just the default setting. So option A, it's the matrix.
The digital view. This has become the dominant metaphor of our age, for sure.
Right. It's code. It's zeros and ones. It's a simulation. This is huge in Silicon Valley right now. Everyone wants to believe we are just characters in a video game, and that if we could just, see the source code, we'd see a bunch of binary switches.
It's a very seductive idea, the simulation hypothesis. It makes sense to us because we build computers. So we assume the universe is a computer. We project our own tools onto the cosmos.
We make God in our own image, and our image is a programmer.
Exactly.
So that's option A. Then there's option B, the woo-woo view.
Tuckles, the woo-woo view.
The universe is this fluid, analog, spiritual wave where everything is connected, nothing is distinct, it's just one big cosmic soup.
The purely analog continuum, the idea that separation is just an illusion and everything is oneness, it's the polar opposite, or so it seems.
Right, and what we're diving into today is a third option, because usually you have to pick a side. You're either a hard-nosed materialist coder or a spiritual hippie.
It is a third option, and it's a third option that is going to sound contradictory at first, but stick with us. The argument here is that those two views, the digital matrix and the analog soup, aren't actually opposites.
Wait, they're not?
No.
Yeah.
They're just different phases of the same thing.
Different phases. Okay, so like ice and water.
Exactly like ice and water. It's the perfect analogy. But instead of temperature, we're talking about information density. We're talking about a gradient ontology.
Okay, see, that's where I need us to slow down. Because the phrase that kicks all of this off is famous. I've heard it a million times in pop science documentaries. It from bit.
John Wheeler,
Yeah.
the legendary physicist, a true giant of the 20th century, worked with Einstein, worked with Bohr.
From bit. And I always thought, and I think most people listening think, that means matter comes from information. Like the universe is a hard drive and the rock in my hand is just a file rendering on a screen. But our sources today are screaming, stop, you're getting it wrong.
We are absolutely getting it wrong. And that misunderstanding is the root of the problem. It's a subtle but profound mistake. If we can fix how we understand that one phrase, if we can understand what Wheeler really meant and what this gradient ontology is proposing, it completely shifts how you see everything.
Everything.
It changes how you see the chair you're sitting in, how you understand your own thoughts, even how you understand gravity.
That is a big promise. But I'm ready to re-engineer my reality if you are.
To do it.
So the mission today is to explore this idea that matter and information aren't two different buckets.
Not two different substances.
They are the same thing at different densities. Where do we even start?
We start with the mistake. We have to deconstruct the it from bit slogan before we can rebuild it. We have to look at why that slogan has led us down a bit of a garden path.
Okay. It from bit. When I hear that, I hear the particle, it comes from the code bit.
Right. And the trap there is taking the word bit literally. When we hear bit today, in the 21st century, what do you picture?
I picture a silicon chip. I picture a transistor. It's a switch. It is either OFF or it is on, 0 or 1. There is no point 0.5. It's binary.
Exactly. We project our modern computer architecture onto the laws of physics. We assume Wheeler meant the universe is made of tiny little switches, like pixels on a screen, that flip back and forth.
Legos. The universe is made of tiny informational Legos.
That's a great image for the misconception, yeah. But if you look at the source material, specifically the essays on gradient continuity, they clarify the historical context.
Yeah.
Wheeler wasn't talking about Python code. He wasn't talking about silicon.
So what was he talking about?
He was talking about distinction.
Distinction.
Yes. In physics, specifically in quantum mechanics, a bit isn't a physical object like a light switch. It is the answer to a yes-no question.
Ooh.
It is the outcome of a measurement. It is the act of distinguishing this from that.
Okay, hold on. So a bit isn't a thing. It's an event.
It's a great way to put it. It's an informational event. Wheeler's point was that the particle, the electron, the photon, only becomes real or defined when we force it to give us an answer.
When we ask it a question.
When we ask, are you here?
Yeah.
And it says yes. That yes is the bit. The bit is the registration of a difference. Before that, it's ambiguous.
So the underlying reality isn't a jagged, pixelated grid of zeros and ones.
No. And this is the first major correction. The universe isn't fundamentally binary. That is a simplified map we draw over the territory.
Okay.
But, and this is the tricky part, it's also not purely analog in the way we usually think.
This is the part that broke my brain a little. I
Yeah.
want to read this quote from the source because it captures the confusion perfectly. It says, "The universe is binary information. False. The universe is a purely analog continuum. False. Holistically, it's neither. It's both, depending on scale and interaction."
It sounds like a riddle, doesn't it? Like something a Zen master would slap you for asking.
It sounds like a cop-out. It's both. How can it be both?
Go back to the water analogy. It's the most helpful tool we have here. If I ask you, is water a solid block? You'd say.
No,
That-
of course not. It's a liquid.
But if I handed you an ice cube?
Then yes, it's solid. But it's still water.
Right. And if I heat it up?
It's liquid, and if I keep going, it's steam.
Exactly. The nature of the water depends on the phase it is in. It depends on the conditions, specifically temperature and pressure. This model, this gradient ontology, is suggesting that information and matter are just phases of the same underlying substrate.
Okay, so the binary world, the world of distinct objects, of me and you, of cup and table, that is a phase.
It is a stabilized state.
Yeah.
It's the ice. We live on the ice. Our brains are built to navigate the ice. We're very good at it.
We're excellent ice navigators.
We are. But we make the mistake of assuming that because the ice is solid, the water underneath must be solid too.
We confuse the crust for the core.
Precisely. We confuse the emergent behavior, the solidness, for the fundamental nature. The binary layer is just a representation, a stabilized state, not the ground of reality itself.
Okay, so if the things, the its, the bits, the distinct objects are just the ice floating on top, what is the water? What is at the bottom of the stack?
To answer that, we have to go down, way, way down. Past the molecules, past the atoms, past the protons and neutrons, we have to go to the quantum layer.
The quantum gradient.
Yes. If you look at the source on gradient ontology, section 2, it describes what exists at the absolute fundamental scale. And it is very clear about one thing. There are no things down there.
No its. No little particles.
No, there are no tiny billiard balls bouncing around. That whole model is, well, it's useful for high school chemistry, but it's fundamentally wrong.
So what is there, if not things?
There are probability amplitudes, there are wave functions, there is superposition.
Okay, superposition. That is a word that people throw around at cocktail parties to sound smart. Oh, I'm in a superposition of wanting to go home and wanting another drink. But let's actually nail down what it means in this physics context.
I think we have to. In this context, it refers to the state of a system before it has been measured, before it has been forced to, let's say, decide what it is.
So it hasn't decided yet?
Correct.
Yeah.
Reality, at the bottom, exists as distributed potential. It's a field of likelihoods. Imagine an electron. We usually think of it as a tiny dot orbiting a nucleus like a planet orbits the sun.
Right, that's the picture in the high school textbook. That's the logo for the Big Bang Theory.
That picture is wrong. It's a useful lie, but it's wrong. In the gradient layer, that electron is a cloud. It is a smear. It is maybe here, maybe there, maybe everywhere at once, all within a certain region.
It's not located at a single point coordinate.
Exactly. It's a haze of potential. It has the potential to be found here and the potential to be found there. But until you look, it's in all those potential states simultaneously.
So at the bottom, reality is a soup. It's not 0 or 1. It's Maybe.
It's point 0.3 here and point 0.7 there, and interconnected everywhere. It is a structured probability field. That is the gradient in gradient ontology.
Yeah.
It is continuous, it flows, it doesn't have sharp edges.
Okay, but, and this is the massive but that I feel physically right now, I'm currently touching a table, I'm tapping it.
I can hear it, it sounds pretty solid.
It feels very solid. It does not feel like a smear probability. It feels like a definite, it stops my hand. So how do we get from that ghostly soup to this hard table?
That is the million-dollar question. How do you get from the gradient to the bit? From the potential to the actual?
Because if you can't explain that, then this is just poetry. It's a nice idea, but it doesn't connect to my world.
Exactly. It requires a mechanism. And the sources introduce a mechanism here that I found absolutely fascinating. They call it the orthogonal intersection.
Orthogonal intersection. That sounds like a geometry problem I failed in 10th grade.
It is geometry in a way. Orthogonal means at a right angle. It implies a cutting across, an intersection of two systems.
And what is doing the intersecting? What's cutting across the gradient?
Interaction, or, as it's often called in physics, and this is a loaded term, observation.
Okay, stop. I need to pull the emergency brake here.
Yeah.
Because every time someone says observation in quantum mechanics, we get into this mystical territory.
Yes, we do.
People start thinking, oh, my consciousness created the universe. Like, if I close my eyes, the moon disappears because I'm not looking at it.
I'm so glad you stopped me there, because that is the most common and I think the most unhelpful misconception. The sources are very, very careful to correct that. This is not about mystical consciousness. This is not about the secret or manifesting reality with your mind.
Thank goodness. Because that's where I usually check out of these conversations.
Me too. Observation in quantum mechanics is simply an interaction that constrains the field. It's a physical event.
Just a physical event.
Yes. A photon hitting an electron is an observation. A chaotic air molecule bumping into a quantum system is an observation. It doesn't require a human brain. It doesn't even require a life form. It just requires contact.
Okay, so it's about interaction. But why do they call it a constraint? What is being constrained?
Imagine that gradient we talked about, that cloud of potential. It's flowing, it's distributed, it's open. Then it hits something. It interacts with a measurement device or another particle or just the ambient environment. That interaction forces the cloud to choose. It collapses the distributed gradient into a localized state. It restricts the possibilities. Before the interaction, it could be anywhere. After the interaction, it must be here.
So the interaction forces the maybe to become a yes or a no.
Exactly. That is the birth of the bit. The bit is what happens when the gradient gets squeezed by interaction. It's the answer to that yes-no question.
Whoa! Okay, let me try to visualize this. So the universe isn't made of bits. The universe creates bits when it interacts with itself.
Yes.
Yeah.
That is the core thesis. You've got it. The universe is not just gradient. It is gradient plus constraint. That is the formula.
That helps me visualize it so much better. It's like, okay, imagine a guitar string vibrating. When it's just vibrating open, it's a blur, right? You can't see the string. It's just a fuzz of motion.
That's the gradient, the potential. It's a wave.
But if I put my finger down on the fret, if I interact with it, I force it to stop vibrating everywhere and vibrate right here. I force it to make a specific note, a definite pitch.
That is a perfect analogy. The vibration is the potential. The finger on the fret is the orthogonal constraint. And the clear note you hear, that's the it. That's the particle. That's the reality we experience.
So we are living in the notes, but the universe is the string.
Beautifully put. And this leads us to the macro scale, because you asked about the table. Why is the table solid if it's made of vibrating strings?
Right. One note makes sense, but a billion notes, a whole symphony, how does that become a table?
Think about what happens when you have billions upon billions of these interactions happening constantly, every nanosecond. The air is hitting the table, the light is hitting the table, gravity is pulling on the table.
It's being observed by the environment constantly. It's being constrained from every possible angle.
Constantly. These interactions pile up. The sources talk about stabilization. Through repeated constraint interactions, these probabilistic states lock into place.
They get frozen.
They get frozen. They become atoms, then molecules, then bodies, then systems. The table is solid because it is in a constant, unbelievably rapid dialogue with its entire environment, and that dialogue is constantly forcing it to be right there.
And that's why the table feels solid. It's a massive, stable pile of constraints, a history of interactions.
Yes, and here's the kicker. At this high level of stability, things behave discretely. They behave like bits. You can knock on the table. It's either there or it's not.
It mimics binary behavior.
Exactly. This is why binary logic works for us humans. This is why digital computers work. We built our logic systems based on the frozen ice on top of the water, and it works great up here.
If I drop a brick on my foot, binary logic says pain. Yes, and that's accurate.
It is very accurate for the macro scale. But the mistake, let's call it the fundamental attribution error of physics, is assuming that because the ice is solid, the water underneath must be solid too.
Right, so when the source says discreteness emerges from the gradient, they're saying that the bit, the 0 and 1, is real, but it's not primary. It's a special effect, an emergent property.
It is a scale-dependent manifestation.
Yeah.
Just like the wave-particle duality. It's not that light is a particle sometimes and a wave other times. That's dualism.
That's splitting it again. It's one or the other.
Right. The holistic view is that light is a field that manifests as a particle when you constrain it and manifests as a wave when you let it propagate. It's the same underlying thing, just interacting with the world differently.
Okay. This is already shifting how I see things. I'm looking at my coffee cup now and thinking, you are just a very stable, very constrained cloud.
A very, very stable pattern of interaction. Just don't let it dissolve on you.
I'll try to keep observing it so it stays real. But I want to go back to the it from bit phrase, because the source material had a section called Correcting the Pipeline, and it called out a specific error in how we think about causation.
Yes, this is crucial. This is where we really turn the old model on its head.
The old view, the naive, it from bit, suggests a linear pipeline, like an assembly line. First, you have information, then information creates matter, like a blueprint creating a building.
Right. Info is the cause, matter is the effect. God writes the code, and the universe renders the graphics.
But the holistic view says, no, that's dualism. That's separating them into two different substances again. You've got your ghost-like information over here and your clunky matter over there.
The new view is mutual gradient.
Mutual gradient. Okay, unpack that.
It means that code arise. They are two sides of the same coin. The phrase to remember from the text is, information condenses into structure. Structure constrains information.
Okay, say that again.
Information condenses into structure. Structure constrains information.
Information condenses into structure. That sounds almost physical, like steam condensing into water.
And that is exactly how you should think of it. The sources use a density model to explain this. And this, for me, was the biggest aha moment in the reading. This is where it goes from abstract physics to something you can almost feel.
Lay it on me.
Okay. So we usually think of information as this abstract, ghostly thing. A thought, a pattern, a code. It feels weightless.
Sure. My thoughts don't weigh anything. The files on my hard drive don't make the laptop heavier.
Actually, they do. A tiny, tiny infinitesimal amount. But we'll get to that in a minute. We think of matter as heavy, hard stuff.
Correct, the it.
The density model says they're the same field, just different densities. Bit, or information, is low-density distinction. It's a pattern, it's a relationship, it's loose. It, or matter, is high-density stabilization. It's form, it's persistence, it's tight.
They aren't two different substances. They're the same field at different pressures or different densities.
Yes. Think of a nebula in space, a giant cloud of hydrogen gas. It's dust. It's very spread out. That's information-like. It's mostly potential. But gravity, which is a form of information itself, pulls it together.
It starts to clump.
It gets denser and denser and denser over millions of years until, boom, the pressure and temperature at the center are so immense that fusion ignites. It becomes a star. That star is matter-like. It's a definite it. But it's made of the same stuff as the nebula.
It's just condensed. It's the same field, just in a different phase.
And the text gives a mind-bending example to prove this isn't just a metaphor. Gravity itself.
Oh, yeah. This part was wild. Gravity is not separate from information. It is information at high curvature density.
Think about what Einstein taught us. Before Einstein, we thought gravity was a force, like an invisible rope pulling things.
Right. The Earth pulls the moon. Newton's apple.
Einstein said no. Gravity is the curvature of space-time. It's geometry. Mass doesn't pull on other mass.
It bends the space around it.
Exactly. Mass tells space how to curve. Space tells mass how to move. It's like putting a bowling ball on a trampoline. It creates a dip, and a marble rolling by will fall into that dip. But what is geometry? What is curvature?
It's information. It's a description of relationships between points.
It's data. It's a set of relationships. So a massive object like the sun is a region of high-density geometric information. It's a place where the information of space-time is highly concentrated, highly curved.
So a black hole isn't just a heavy rock, it's a region where information is so dense, so curved, that it traps light.
Precisely. A black hole is the ultimate it, because it is the ultimate density of information. It's where the gradient gets tied into a knot, so tight that not even the speed of light is fast enough to escape the curvature.
That is terrifying and beautiful. It reframes the whole thing.
And on the flip side, the sources mention something much closer to home. The ego.
My ego, my personality, my sense of self.
Your sense of I.
Yeah.
Yourself. What is that? It's not a physical object you can touch. You can't perform surgery and remove the Johnness from John.
No, it's a pattern. It's a collection of memories, habits, beliefs, reactions.
It is a localized condensation of informational pattern. It's a high-density knot in the information field of your nervous system.
Man, so I am just a knot in the field.
You are a stable basin in the gradient. You are a place where the information has swirled together and stabilized for a little while, about 80 years, hopefully, before it relaxes back into the flow.
I feel like I need a minute to process that. My sense of self is a dense spot in a field. But it actually makes sense. If everything is this field, then things, me, the table, the star, are just where the field gets thick.
Where it knots up, where it condenses into a semi-stable pattern.
There was an analogy in the source notes that I absolutely loved because I'm a huge nerd. It brought up Star Wars.
Yes, the Jedi and the Empire. This is a great way to illustrate the point about escaping binary thinking.
Right. So usually we look at Star Wars and we say, Jedi are good, 1. Empire is bad, 0. It's a binary moral system, light versus dark.
It's the ultimate dualism. And George Lucas, he built the whole mythology on that classic dualism. It's very effective storytelling.
But in this gradient ontology, how would we describe them? Because clearly there is a difference between Luke Skywalker and Emperor Palpatine.
The source says, they are informational density states inside a field.
The field being the Force.
Exactly. The Force is the gradient field. The light side represents one type of stable basin, one way the field can organize itself: peace, passivity, flow, harmony. It's about aligning with the gradient, listening to it.
And the dark side?
The dark side represents another stable basin, a different organization of the field: passion, aggression, control. It's about constricting the gradient. It's about imposing high-density will upon the field, bending it to your pattern.
So they aren't total opposites that cancel each other out. They are just different curvatures of the same force, different ways of interacting with the same underlying reality.
Gradient curvature. And think about how Anakin Skywalker becomes Darth Vader.
He doesn't just flip a switch one morning.
No, it's a slide. It's a descent. He slides down the gradient. He moves from one basin of attraction to another. Fear leads to anger. Anger leads to hate. It's a phase transition. He slowly condenses into a different structure.
And the lesson there is that there is no switch. You don't just wake up one day as a Sith Lord. You phase transition into it over time, decision by decision.
It from bit is not causation. It is phase transition. That's the catchphrase the source gave us.
It's a powerful reframing. It stops us from looking for the cause of reality, like who pushed the button, and starts making us look at the structure of reality. How does it flow? How does it curve? What are its tendencies?
Exactly. It shifts the entire mode of inquiry.
Okay, I'm with you on the philosophy. It's beautiful, it's elegant, it solves the dualism problem, but I have to play the skeptic.
Please.
Is it true? Or is this just really cool poetry? Is there any hard science to back this up?
That is the responsible question to ask. Is there any science here? Or is this just quantum mysticism?
Right, because we've all seen those documentaries where they say quantum mechanics proves you can walk through walls if you believe hard enough.
And that is exactly what we want to avoid. The sources did provide a section called scientific scaffolding, because obviously gradient ontology isn't a standard chapter in a high school physics textbook yet, but it's built on very real, very rigorous research threads.
So let's check the foundation. Let's kick the tires. What is the science holding this up?
It synthesizes a few heavy hitters. We've already mentioned Wheeler. But let's look at the mechanism of how bits emerge from the soup. We talked about the environment observing things. There is a specific technical term for this: decoherence.
Decoherence. Okay, what is that in plain English?
So remember our quantum soup, our superposition where the electron is everywhere at once.
The vibrating string.
Right. Why don't we see that in real life? Why doesn't my coffee cup look like a blur? Why isn't it in a superposition of being on the table and on the floor?
Because it's decohered.
Yes. Decoherence is the process by which that delicate quantum state gets entangled with the environment. Imagine you are trying to hold a delicate, complex thought in your head. A daydream.
Okay.
and you are in a library, it's quiet, you can maintain that superposition of ideas.
Sure, I can hold the whole thing in my mind.
Now imagine you walk into a crowded nightclub. Loud music, people bumping into you, lights flashing.
My thought disappears. It collapses. I can't hold it.
Exactly. The environment measures you. The noise, the heat, the air molecules, they are constantly bumping into the quantum system and effectively leaking its quantumness away. They force it to define itself. Where are you? Where are you? Where are you? A billion times a second.
So the coffee cup is being bombarded by air and light so intensely that it can't maintain a superposition. It has to pick a spot and stay there.
It is being forced into a single, classical-like state by the environment. This is related to another concept mentioned in the sources, quantum Darwinism.
Quantum Darwinism, that sounds intense. Survival of the fittest particles.
In a way, yes. It was proposed by a physicist named Wojciech Zurek. It's the idea that the fittest quantum states are the ones that can imprint themselves on the environment most effectively.
Imprint themselves, like a fossil.
Sort of. Think about looking at that table. You see it.
Yeah.
I see it. If someone walks in the door, they see it.
We all agree it's there. It's
Yeah.
objective.
Why? Because the table has scattered photons in every direction. It has created redundant copies of its information, its position, its shape, its color in the photon field. It has spammed the environment with the message, I am a table.
So the table is real because it has successfully gone viral in the environment.
That is a brilliant way to put it. Objective reality is just the information that has survived the noisy environment and replicated enough times that we all agree on it. The things that can't make copies of themselves just fade back into the quantum fuzz.
That is wild. So objective reality is just consensus, a consensus between all the parts of the universe.
It's consensus born from stability. It's the bits emerging from the soup because they are stable enough to survive the club and tell everyone they were there.
Okay, so that backs up the emergence part. That explains how we get its from the gradient. What about the information is physical part? You mentioned earlier that my thoughts might have weight.
For that, the sources point to Landauer's principle. Rolf Landauer. He was an IBM physicist in the 60s, and he proved something profound. Information is physical.
Meaning it's not just in our heads, it's not abstract.
Meaning that processing information, specifically erasing information, has a minimum thermodynamic cost. It must, by the laws of physics, create heat.
Like my laptop getting hot when I'm editing video?
We usually think that's just because computer chips are inefficient.
Uh-huh.
Resistance in the wires. But Landauer proved that even if you had a perfect computer with zero resistance, erasing a bit of information, changing a 1 to a 0, would still release a tiny irreducible amount of heat.
Why? Why does erasing a bit create heat?
Because you are reducing entropy. You are organizing the universe. You are taking a system that could be in two states, 1 or 0, and forcing it into one state.
Right.
That's a decrease in disorder, a decrease in entropy.
And the second law of thermodynamics says you can't do that for free.
You can't reduce entropy here without increasing it there. You have to pay the bill. And the bill is paid by releasing heat into the environment.
So to manipulate bits, you have to do work in the physical world. You have to pay an energy bill.
Correct. Information isn't free. It has an energy equivalent. And since Einstein told us that energy equals mass, EMC22,
Then information equals mass, or at least is inextricably tied to it.
in a very real sense, yes. This supports the density model. If information has energy, and energy is related to mass, then information and matter are on the same spectrum. They aren't two separate kingdoms.
It's all connecting. The scaffolding holds up. It's not just poetry. It's an interpretation of the physics we already know, a way of putting it all together.
It's a way of connecting the dots that we usually keep separate. It bridges the gap between the equation on the blackboard and the experience of living in the world.
So let's bring this home to the listener. We've talked about quantum soup. We've talked about gravity as information. We've talked about Star Wars. We've talked about thermodynamics. But why does this matter? Why should I, as a regular person trying to get through my Tuesday, care about gradient ontology?
It matters because our worldview shapes how we interact with everything. And right now, most of us, whether we know it or not, are operating on a dualistic worldview.
Dualism. Splitting things in two.
Mind versus body. Software versus hardware. Us versus them. Man versus nature. We see the world as made of separate, distinct objects that bump into each other. We put things in boxes.
And gradient ontology says that's an illusion, or at least an incomplete picture.
It says that is a low-resolution view. It says that the separation is just a phase state. It's the ice. Holism, the integrated view, asks us to see the connection, to see the water underneath.
It's seeing the wave, not just the particles.
Think about the implications for something like artificial intelligence. This is the biggest conversation in the world right now.
Oh, absolutely. Everyone's talking about it.
If we are dualists, how do we talk about AI? We ask, is the AI conscious or is it just code?
Binary. Yes or no. Is it a person or is it a toaster? And we get stuck.
And we get stuck in these endless, fruitless arguments. It can't be conscious because it's silicon, but it talks like a person.
But if we use the gradient model...
Then it's not a binary switch. It's a question of density. It's a question of complexity and integration.
Yeah.
It's a spectrum.
It's a gradient of cognition.
Exactly. We can ask, how dense is the information integration in the system? How stable is its internal model of the world? It allows for a much more nuanced and frankly more productive conversation. Maybe it's not human conscious 1 or rock 0. Maybe it's at 0.4 on the gradient or 0.7.
That is so much more helpful. It stops the panic and lets us actually analyze what we're building.
Or think about your own health. Mind and body, we treat them as separate. You go to a doctor for your body and a therapist for your mind.
And never the twain shall meet. The insurance codes are completely different.
Right. But in this model, the mind is just a lower density, more fluid pattern of the same field that makes up the body.
The body is the condensed mind, the stabilized mind.
In a way, yes. They are mutual gradient. They co-create each other. Remember the phrase, information condenses into structure. Stress, which is an information pattern, condenses into inflammation, a physical structure.
And structure constrains information. A physical injury, a structural problem, absolutely constrains your mental state.
You cannot treat one without the other because they aren't two things. They are phase transitions of one system. It points toward a more holistic approach to medicine, to psychology, to everything.
That is actually really practical. It changes how you solve problems. You start looking for the one cause, the silver bullet, and you start looking at the whole system, the whole
You
field.
start seeing the flows, you start seeing the gradients, you start thinking about the patterns, not just the pieces.
I love the mantra the source gave us. Where information condenses, structure appears. Where structure relaxes, information disperses.
It's almost therapeutic, isn't it?
It really is. It makes me feel less isolated. If I'm just a knot in the field, then I'm connected to the rest of the field. I'm not this lonely little particle bouncing around in empty space.
You are continuous with the universe.
Yeah.
Your boundary, your skin, is just a rapid change in density, not a wall. You are exchanging atoms and energy and information with the room right now. You are literally breathing the room.
Man, okay. We have covered a massive amount of ground. From Wheeler's it from bit to the quantum gradient to the emergence of the macro world.
It's a long journey for the soup to the table.
But the destination is this holistic view, this integrated view.
The view that reality is one thing, one field, expressing itself as potential, as interaction, as matter, as thought.
I want to leave the listener with that final provocative thought we touched on. The idea of the ego as density.
Yes, this is the one to chew on. This is the homework assignment.
Because we spend so much of our lives defending our ego, defending who we are. I am this type of person. I believe this. I am not that.
We treat the ego as a fortress, it that must be protected at all costs, a solid, unchanging thing.
But if it's just high-density information, if it's just a knot, a stable pattern,
Then it can be reshaped, it can relax, it can expand. If you realize your identity is a condensation pattern, you realize you have the power to change the pattern. You aren't a rock.
you aren't a rock.
You're a jazz chord. You're a complex vibration. You can change the notes. You can modulate to a new key. You're not stuck.
That is beautiful. You aren't a rock. You're a jazz chord. I'm putting that on the T-shirt.
And practically, for critical thinking, when you hear an argument, don't just look for the binary right versus wrong. Look for the density. Where's the information clumping? Where is it sparse? Where's the energy? See the field.
That is the ultimate takeaway. Stop looking for the switches. Start looking for the dimmer knobs. See the gradients and everything.
Exactly.
Okay, that's it for this deep dive. My brain is officially full, but in a good way. I'm going to go stare at my coffee cup and try to see the stabilized intersections within a continuous field.
Just don't let it decohere before you drink it.
I'll try my best. Thanks for listening, everyone.
See you in the gradient.